This is the demonstration part of the simulation program. In this program, there are different parts, and different parts of the model will list out on the main menu panel. They are divided into different categories. User can click the model from the categories. By clicking the corresponding button, the new windows will pop up and show the simulation. The first one I would like to demonstrate would be the check circuit simulation system. This system can monitor the whole status of the whole main line. First of all, we can add the chain on the check by clicking the Add Chain button, and the chain will start automatically. On the top left corner, we can observe the status of the chain, such as the chain position, chain direction, and the station time. It will display the system time. We can change the status of the chain, such as the chain direction and the chain speed, and etc., by clicking the corresponding buttons. The ATS will set the width of the chain and change the status of the speed switches automatically. We can turn off the ATS system by clicking the Off button here. There are legends to explain the meanings of different colors of block. For example, for the purple one, it means the block error. The right-hand side will show the history of the whole system, such as the chain stationing, chain stop, direction change, status change of speed switches, and etc. It will update immediately. In case the history not updates automatically, we can click the Refresh button to help to refresh and update the history. The history of the ATS system will be saved in this test file. By checking the test file, we can check the past history again. There is a suspend message button. By clicking this button, we can send the delay message to the media and tell the public the train service is suspended. We can create the fault of the block manually by just clicking the block. For example, I set the fault here by just clicking the block. When the train comes to the fault block, it will stop automatically. We can also set the route manually. For example, we can set the speed switches. Here is an example. First of all, I set the start point, and then I check the destination. The route was set. The next one would be the check size circuit. First of all, we need to select the number of lines of the signal lines. We can select 2 lines first. Then we can click Start to start the train. In this simulation model, we can create the fault of different check size circuit. Once there is a fault on the check size circuit, the signal light will turn red and the train will stop. Let's see. First of all, we create a fault in region 3. We can see the signal light of region 3 become red and the train stop automatically. To restart the train, we can restore the fault path and the train will continue. We can select the other type of the signal. we can select 3 lines. Once we change the signal lines into 3 lines, there will be one more warning signal displayed in the system. It will display between the red signal and the green signal. The third one would be the SO counter. First, we need to select the number of lines of the signal line. Then we can click Start to start the chain. There are many SO counters located at different regions. There are readings near the SO counter. The signal will display green only when the SO counter contents between the regions are the same. We can set fault of the SO counter to change the contents. For example, we change the content number of this SO counter, and this signal light will turn red and the chain will stop automatically. The chain will continue only when the SO counter will be fixed. We may fix the content of this SO counter and the chain will continue. This is the simulation model of automatic warning system. The chain will pass through 3 main areas. They are the permanent magnet, the electromagnet, and the braking area. First, we need to select the status of the signal. For example, we set green and start the chain. The permanent magnet will put the AWS to standby mode, and the electromagnet will turn off the AWS if the signal display is green. The chain would not decelerate in the braking area and pass through the signal. Once again, we can change the status to red. The permanent magnet will put the AWS to standby mode. But this time, the electromagnet will turn on the AWS. Once the chain enters the braking area, it will start braking to let the chain stop in front of the red signal. The chain driver can press the cancel button to pass through the chain to the red signal. For the chain stop device will lift up when the signal turns red. It will trip the emergency braking button under the chain to prevent the chain pass through the red signal. First of all, we need to set the status of the signal. For example, we set green and start the chain. For the signal turns green, it means that the chain is allowed to pass through the next block. The emergency braking will not apply. The chain is under normal operation. However, when we change the status of the signal to red, the chain stop will lift up. Chain would not be allowed to go to the next block. If the chain passes through the red signal, the emergency braking will apply because the chain stop tripped the emergency braking button under the chain. The chain can continue once the red signal restored to green. Then, the breaking plan of the chain. For this distance to go system model, it will simulate the ATP to select different plan to stop the chain. This model will simulate the chain breaking according to different plan. They are the speed curve, normal breaking curve, warning breaking curve, and emergency breaking curve. User can observe the change of cap signal and chain speed of the program. First of all, we can select the speed coded system and see the change in chain speed. It will decrease step by step and stop at here. We can restart the program to see other plan. For example, the normal breaking. It will break along this green line and stop here. For the warning breaking will be stronger, and it will break the chain along this yellow line. The chain speed will decrease faster. For the emergency braking, the braking force will be strongest, and the chain speed decrease faster. This is the video corner of the program. The videos will explain how to use this program. In case user cannot get the results, there are some demonstration videos to let user to see the results of different simulation programs. The video will play once user click the corresponding button. Here is an example. Once user click the button, the video will play. User can pause the video and play again. User can double click to enlarge the video. The video will stop by clicking the stop button. There are some of the simulation model will explain the different signaling techniques by the animation and the description. User can change the status and watch the description and the picture display. Because of limited time, I would not show all the simulation model. You may scan this QR code and visit my YouTube channel for more demonstration videos. That's the end of the demonstration video. Thank you for watching.